Hi, this is Ms. Wiles, and in this video we'll be covering factoring by grouping. In previous videos we've covered factoring by grouping or factoring quadratic equations when we have a leading coefficient of 1. And by that leading coefficient of 1, I mean a particular problem like, let me go back, we'll add a thing here. Something like x squared minus 4x plus 4. When we have a leading coefficient of 1, we don't have any greatest common factor or anything to factor out. We've already checked that, and we have this leading coefficient of 1. We find the factors by creating our table or by doing some guess and check in our head. We're looking for two numbers, the factors of AC with a sum of B. So when I look at this, A is 1 because we have our standard form, ax squared plus bx plus c, and A is the coefficient of x squared. B is the coefficient of x, which is the linear term, and that's a -4 in this one. And C is the constant term, and in this one it's +4 because of the +4 on the quadratic equation. So then we're looking for factors of AC. Well, AC is 1 times 4, which is 4. And that's our target number there for that column. And in the second column, our sum being B, B is -4, so that's our target number for that column. When we find two numbers that give us the target number in each column, then we've found our factors. And you may start off with 1 times 4 being 4, then you look at what you have in your sum column, and since the sum column is a negative number, one of those has to be negative, because that's the only way that actually both of them would have to be negative. Both of them would have to be negative because you have to think about the properties of numbers, and the only way that you can multiply two numbers and get a positive and add them and get a negative is if they're both negative. So we try -1 times -4. Well, that does give us 4, but -1 plus -4 gives us -5, and we know that's not the combination of numbers that we need. So then we move on from the 1, and we say, okay, 2. Well, 2 times 2 is 4, and because I'm looking for a sum that is negative, I know that both of them would have to be negative, because -2 times -2 is 4. And -2 plus -2 gives us our target number for the sum column of -4. So this is the line that gives me what I need. Because the product is 4 and the sum is -4, then the factors that I have to work with are -2 and -2. That means that when I factor this quadratic, I have x minus 2 times x minus 2. So that's factors. Now, if I want to know the solution, and these are the factors, if I want to know the solutions, I use the zero product property. The solution of any equation is when y equals 0. And y will be 0 in this particular equation when x minus 2 is 0. X minus 2 is going to be 0 when we solve this little one-step equation. Sometimes it'll be a two-step, but this one is a one-step equation. And we solve this by adding 2 to both sides of the equation to isolate the x and find that x equals 2. Because both of my factors are exactly the same in this one, I only have to do it one time, and my solution is x equals 2. However, not all the time will my leading coefficient be 1. Sometimes my leading coefficient is something else, like this problem. This problem has 6x squared minus or plus 16x plus 8. When we factor any quadratic equation or any equation at all, we need to look at all the terms. And if you recall our list of our checklist of general things to do, number 1 is to check for greatest common factors. We need to look at each of these 3 terms and determine if those 3 terms have anything in common. So when I look at the 6, the 16, and the 8, I'm going to look at those numbers and I'm looking for the greatest common factor. So as we look at the 6, the 16, and the 8, when we think about the greatest common factor, there's a number that will go into all of them. All of them. And you start with the smallest number. Will 8 go into all of the numbers, you ask yourself? You're like, actually, the smallest number is 6. So you start with the 6. Will 6 go into all of the numbers? No. But what's the highest number that will go into 6 besides 6? And that's 3. Will 3 go into all the numbers? No. There's one more number that will go into 6 that will help, and that's 2. 2 will go into 6, 2 will go into 16, and 2 will go into 8. So we have a greatest common factor that we need to factor out of this equation. When we factor 2, oh, and by the way, we should definitely at least look at the variables. Does each of the terms have a variable? No. If each of the terms doesn't have a variable, then we don't have a variable that's the greatest common factor. When we factor the 2 out of the 6x squared, we're left with 3x squared. You can think of it like this. We're dividing that 6 by 2. When you factor the 2 out of the 16x, you're left with plus 8x. You can think of it as dividing the 16 by 2. When we factor the 2 out of 8, you're left with 4. Positive 4, and you can think of that as dividing that 8 by 2. Now we've got a greatest common factor that's part of our factors, but we've got this quadratic equation that's 3x squared plus 8x plus 4. It still doesn't have any greatest common factors, but the leading coefficient is not 1. So we have to we have to add something. You know, every time you think you've got something right in math, you're going to add a little bit of something. And that's why you got to keep up so that you can be able to add that little bit of something. Now we do know that we have this table that we're looking for the factors of AC. And we're looking for the sum to be equal to B. Well, that still applies for the quadratic part of the equation. But now A is 3, B is 8, and C is 4. So A times C is 3 times 4, which is 12. Our target number in the first column is 12. Our target number in the second column is still adding those two numbers together. When will we get 8? So now it's a matter of checking and guessing, and how good are you with numbers and multiplication facts and doing this thing quickly in your head. So let's pause here while you think about what two numbers can I multiply and get 12 and add them and get 8. So once we thought about that process here in class, we thought about 1 times 12 first. That does equal 12, but 1 plus 12 is 13. Then from the 1, go to the next likely number, 2. Does 2 go into 12? Is there a multiplication fact with 2? And it's 2 times 6. And 2 plus 6 is 8. And this is my target line. I have hit my target in both columns. Now you may jump on that and think that that means that you've got your factors there, but you don't. And the reason that you don't is because this leading coefficient is not 1. It is not 1. And because of that, we are going to use this 2 and this 6 to split the linear term. I'll show you what that means right here in this step. We split that linear term. We leave the 3x squared just like it is. Of course, the 2 stays. But we're going to split that linear term, that 8x, we're going to split that into a plus 6x and a plus 2x. And then the plus 4 still stays. Now you should agree with me that 6x and 2x does equal 8x. 6x and 2x equals 8x. Now you may ask why I put the 6x first and the 2x second. And it's because of what I know is coming in the next step. Look for a relationship between these two numbers. There's a nice relationship between the 3 and 6, and a nice relationship between the 2 and 4. Now, there is a relationship between the 6 and the 4, but there's no relationship between this 2 and this 3, and that's why you wouldn't group the 2 and the 3 together. Now, don't worry, I'll pause for any questions that you have in class, but let's finish this out. When we say that we're factoring by grouping, we're going to split it up. We're going to split it up to where we have 3x squared plus 6x, and then plus 2x plus 4, because we're going to be looking for the greatest common factor of each of those groups. This is too much, isn't it? But we have to get through this process as long as we don't have multiple choice. If we have multiple choice, there's some ways to check. So I look at the 2 stays out here where it is. It's already out. But I look at the 3x squared and the 6x. What do they have in common? What they have in common is the 3 for the 3 and the 6, and the x for the x squared and the x. That's what they have in common. So if I divide that first term by 3x, I'm left with x. Then if I divide that 6x by 3x, I'm left with positive 2. And I'm going to do the same thing. See, each step by itself is not difficult. Come on. Each step by itself is not difficult. It's knowing when to do it and to be able to focus on that one step at a time. So now we look at the 2x plus 4. The 2x plus 4 has something in common too. If it doesn't, it means that I haven't grouped them properly. The 2x and the 4 have a 2 in common when I look at them separately. The 2x can be divided by 2 and the 4 can be divided by 2. It's their greatest common factor. When I divide the 2x by 2, I'm left with x, 1x. And when I divide the 4 by 2, I'm left with 2. Now at this point, you can look at it and you'll know if you're right. You are right if these two binomials match. If those two binomials match, then you can go to the final step. And the final step is to group the 3x and the 2 together and bring the x plus 2 together. And this is your final answer.